So in our third video in Lecture 2, we're going to talk about Euclid's elements, Euclidean geometry. Basically, it's the first marriage of logic and geometry and math. So it's very nice there. And I'll illustrate one of those marriages in a simple proof by contradiction at the end. So what's Euclid's geometry? Well, as mentioned before, Euclid's elements contain 23 definitions, 5 axioms, and 5 postulates. So basically, what's logic? So logic originally meaning the word or what is spoken, but coming to mean thought or reason. So logic is the fundamental tool we have as humans to basically deduce or discover new things in the world. So Einstein had thought experiments, and then he logically deduced from those thought experiments that, for example, mass and inertia are the same, and all it's everything kind of is relative. If you want, we'll get into that more. So logic is the systematic study of form of valid inference. So a valid inference is one where there is a specific relation of logical support between the assumptions of the inference and its conclusion. Okay, so you can take many logic courses. Logic is the underpinning, uh, uh, element of all science, especially computer science and engineering. Logic gates, logic in algorithms, math is all basically just logic. Uh, Even law, okay, is an application of logic to laws, right? So just some introduction to logic. We're not going to go. It could be a whole course on logic, actually. So a conditional statement contains both a hypothesis and a conclusion. If hypothesis, then conclusion. You usually P is usually the hypothesis, Q is the conclusion. So this is original statements. If P then Q can be written P implies Q. For example, if a number is divisible by 6, then it's divisible by 3, PQ. Converse, if Q then P, which is the converse of this. It's equivalent statements. For example, if a number is divisible by 3, then it's also divisible by 6. The inverse statement uh, is not P implies not Q. Okay? Not P and not Q. So if a number is not divisible by 6, then it's not divisible by 3. Something called not contrapositive. Okay. Uh, so these are actually equivalent. These two, the original statement and its contrapositive are equivalent. If not Q, then not P. So if a number is not divisible by 3, then it's not divisible by 6. Okay? So two statements are equivalent. So original statement and the contrapositive here are equivalent. And the converse and inverse are equivalent statements too. So if both original and converse are true, then the statements are equivalent. Okay, if and only if, that is. So for example, a number is divisible by 3 if and only if the sum of its digits is divisible by 3. You can prove both ways. This implies that, and this implies that. So again, like logic has a lot of elements. You can look at some of its elements here in this link. The proof by contradiction is this method works if you're assuming an implication is not true, then you derive something that contradicts the original state, okay? Which means that then the original statement was wrong. Okay? So back to Euclid elements. His 23 definitions more or less defines a point. a segment. So a point is a location in space. A segment is a straight path between two endpoints. A line is a straight path that extends infinitely in both directions. The plane is a flat surface that extends infinitely in two dimensions. Now here are Euclid's 5 axioms listed as follows. So, for example, 1. Things which are equal, this is basically mathematics related, to the same thing are also equal to another. So basically, if A is equal to B and B is equal to C, then A is equal to C. If equals be added to equals, then the wholes are equal. Yeah. And if equals are subtracted from equals, the remainders are equal. Things which coincide with another are equal to one another. The whole is greater than the part. So if you look at this video here, between 6 minutes and 7 minutes, it describes all of these Euclid's 5 axioms in more detail. Switches here. Just press here on the PowerPoint. Euclid's 5 postulates, which are geometry related, are as follows. Okay, so to draw a straight line from any point to any point. To produce a finite straight line continuously in a straight line. Okay, so to understand, let's just look at the 5th one, the called the parallel postulate, which we'll run into later when we talk about non-Euclidean geometry. So the parallel postulate says the following. Basically, two parallel lines don't intersect. Okay? Two parallel lines don't intersect. Right, makes sense, right? Two parallel lines, basically they never intersect. So more formally, he said that if a straight line falling on two straight lines makes the interior angles on the same side less than two right angles, the straight lines, if produced indefinitely, will meet on that side on which the angles are less than two right angles. Anyways, it just means two parallel lines don't intersect. And you can watch this YouTube video here, link, to get a more better idea of Euclid's 5 postulates. Prior. Now, so if Euclid's postulates, I'm going to prove very nicely that given two different points, there's exactly one line that contains them. That is, given 2 points A and B, okay, there's only exactly one line that contains these 2 points. Okay? So how do you prove this? We're going to prove this by contradiction. So the contradiction method again is you assume that it's not true, and then from there you prove something that's very ridiculous. Therefore, the original assumption must be wrong. Basically, okay? So the two lines intersect at most at one point. Basically, that's what I'm saying. So proof by contradiction. Now, suppose this theorem is false. Okay, this statement is false. Two lines intersect at most one point. Okay, so two lines intersect at most at one point. So here's two lines. It's got to intersect at most at one point, right? Now suppose not. Suppose they intersect. So this is say L, line L, and this is line M. Okay. Now suppose line L and M they intersect at more than one point. Okay, more than one point. That is, they intersect at 2 points A and B. Then the points A and B will have two lines containing them. Right? But this violates this postulate that given any 2 points, there's exactly one line that contains them. Right? So that is between points, there's exactly one line. Okay? So because then the points at A and B would have two lines containing them. Right? That's violating this postulate that there's only uh, one line containing 2 points. Right? So this original assumption that the two lines must intersect at more than one point must be wrong because you derive this contradiction here. This is a contradiction. Okay,